Myself, Rajendra Eskarale. My qualification is chemistry BA and experience is of 28 years. Now, today we are going to discuss about the internal energy or intrinsic energy, which is denoted by capital U. Now here first we will discuss about the definition. Now, what is the definition of internal energy? Definite amount of energy possessed by the substance or sum of all forms of energy stored in a substance this substance means a system or the amount of heat absorbed or evolved during a reaction at constant volume and temperature. Now this is the standard definition. Internal energy is nothing but the amount of heat absorbed or evolved during a reaction at constant volume and temperature. That means here this constant volume word is very important. Whenever the volume remains constant, then that heat is called as internal energy. But if here constant pressure is used, then this is not an internal energy, that is called as enthalpy, which is the next parameter. Now it depends upon the factors like number one, chemical nature of the substance, chemical nature of the substance, temperature and pressure etc. Now here it is represented by U. In old system, it is represented by capital E. Now here it is a state function. Meaning is that it depends upon the state of a system, that is initial and final state of a system, and not on the path. Now it is made up of kinetic energy and potential energy of the constituent particles. Now here that means U is equal to kinetic energy plus potential energy now we write down first kinetic energy. Here it is arrived due to motion of particles like translational motion, vibrational motion, and rotational motion. That means here kinetic energy is equal to translational energy plus vibrational energy plus rotational energy. Now here write down second potential energy. It is arises due to the different types of interactions between the constituent particles. Now here it consists of electronic energy, comma, energy due to molecular interaction and nuclear energy etc. Now your potential energy equal to electronic energy plus energy due to molecular interaction plus nuclear energy. Now we are write down limitation. Internal energy means definite amount of heat or definite amount of energy possessed by the substance, or sum of all kinds of energies stored in a substance. That substance acts as a system, or the amount of heat absorbed or evolved during a reaction at constant volume and temperature is called as internal energy. Now it is not possible to calculate the absolute value of internal energy U possessed by a substance. This is because here it is not possible, it is not possible to calculate or to find out the absolute value of accurate value of different types of energy like translational, vibrational, rotational and chemical energy stored in a system. Now here write down change in internal energy delta U. Now what is the definition of change in internal energy delta U? Difference in the internal energy of the final and initial states of a system. Now here it is denoted by delta U. Example first, for a process suppose A changes to B, here A is the initial state and B is the final state. That means here let UA and UB are the internal energy in the initial and final states respectively. Now here, hence change in internal energy delta U between two states is given as delta U equal to UB minus UA. Now second here, for a chemical reaction R changes to P, this is reactant and this is product. Here let UR and UP are the internal energy of reactants and products respectively. That means here, hence change in internal energy delta U between reactants and products is given as delta U equal to UP minus UR. Now here write down case 1. If the internal energy of the product is more than that of reactant, that means your UP is greater than UR, but delta U equal to UP minus UR. Hence, delta U is positive. Now here case 2. If the internal energy of the product is less than reactant, that means here UP is less than UR, but delta U equal to UP minus UR, and here hence delta U is negative. Now then write down change in internal energy act as a state function. Here write down delta U. Now here change in internal energy delta U for a different paths is same. Though the initial and final states are same. Hence, the change in internal energy delta U depend upon the states of a system. Hence, it is not a path function, it is a state function. Now here write down monitoring of the energy is transferred in and out of a system. This topic is only for MBSE 12 and MHT-CET. But this is also important for the Central Board of Secondary Education, NEET and JEE. The two important forms in which energy appears is heat and work. Now, heat is the random form of energy and work is the organized form of energy. The internal energy U of a system changes in such a way that energy is transferred in and out of a system in the form of heat and work. The internal energy U of a system changes in such a way that energy is transferred in or out of a system in the form of heat and work. Now here the energy is transferred in and out of a system need to be monitored in order to know the change in internal energy delta U. Now here number 1, it is added to the system when the energy is transferred in a system by heating or by performing work on the system. Listen here. It is added to the system when the energy is transferred in a system either by heating or by performing work on the system by the surrounding. Now second, it is removed from the system when the energy is transferred out of a system by cooling or by performing work by the system on the surrounding. Now here write down if example A, if 20 kilojoule of energy is transferred in a system by heating, it is added to the system. Now second, hence here write down 30 kilojoule. Hence delta U is equal to plus 30 kilojoule. If second, if 20 kilojoule of energy is transferred in a system by performing work on the system by the surrounding. Hence here, that means it is added to the system, and hence here delta U equal to plus 20 kilojoule. Third example, if 10 kilojoule of energy is transferred out of a system by cooling, and 15 kilojoule of energy is transferred out of a system by performing work done by the system on the surrounding. That means these are removed from the surrounding system. That means here delta U equal to minus 10, minus 15 equal to minus 25 kilojoules. Now then next example. if 10 kilojoule of energy is transferred out of a system by cooling and 25 kilojoule of energy is transferred in a system by performing work on the system. That means here it is removed from the system, that is here delta U equal to minus 10 kilojoule, and here write down it is added to the system that means here delta U equal to plus 25 kilojoule. That means here net or resultant delta U equal to minus 10 plus 25, that means which is equal to plus 15 kilojoule. Now here keep in mind number one, change in internal energy delta U of a chemical reaction always carries a sign, whether even if it is positive. That means you can use the sign before delta U like this, negative, positive. Now second, warm calorimeter, warm calorimeter is used to measure the change in internal energy delta U of a chemical reaction. Now keep in mind here, this is the name of the instrument, that is warm calorimeter, is used to measures the change in internal energy of a chemical reaction. Now take next. Zeroth law of thermodynamics. Only for NEET and JEE. Now here write down statement. In comma inverted comma, if a system A is in thermal equilibrium with the system B and the system B is in thermal equilibrium with the system C, then the system A is in thermal equilibrium with the system B whatever may be the composition of the system. Now here write down or. If the two systems are in thermal equilibrium, then they have same temperature. Or and if they are not in a thermal equilibrium, they have different temperatures. That means this is the statement of zeroth law of thermodynamics. This is only for NEET and JEE. But keep in mind this statement. Thermal equilibrium means, thermal means temperature. That means here the temperature remains constant. Now this is regarding about internal energy or intrinsic energy. Then next, change in internal energy. Then next, monitoring of the energy is transferred in or out of a system. And then next, zeroth law of thermodynamics. Keep in mind the name of the device, that is bomb calorimeter, is used to measure the change in internal energy delta U of a chemical reaction, and the remaining part of this unit will be discussed in the next lecture.